My talk is about RISC-V inverted bitwise instructions. There are 5 such instructions, and not or not, exclusive nor, vector and not taking 2 vectors, and vector and not taking a vector and a scalar. LLVM already emitted these instructions using these simple patterns. For a bitwise operation with an inverted operand, it emitted the inverted instruction. Of course, real selection dark patterns are more verbose than what you see in this table. I made 3 simple optimizations. First is for a bitwise operation with a constant. The second is for doing the inverted operation in the loop. And the third enables some target-independent transforms emitting a vector and not. Now I will explain my first optimization. RISC-V instructions are 32-bit, which is not enough to load any 32-bit constant. So depending on the value of the constant, you use either an add instruction, load upper immediate, or load upper immediate followed by addition. So if the inverted constant takes fewer instructions to load, it makes sense to emit the inverted operation with the inverted constant. A typical example for 32-bit constant is we avoid setting the low order bits to ones. And instead of 3 instructions, we emit 2 instructions, including an inverted bitwise operation. 64-bit constants are more complex. There's a whole file in LLVM that is over 500 lines of code, and it emits a sequence of several different instructions just to load a constant into a register. And in order to tell if my transform is profitable, I ask it about the cost to load the original constant, the inverted constant, and I apply my transform if the inverted constant takes fewer instructions to load. My second change was for loops, and if there's an inversion before the loop and a bitwise operation inside the loop, we sync the inversion so we can emit the inverted operation. I implemented it just for RISC-V. If you work on x86 or ARM, please support this optimization. My last change was just enabling some transforms. I came across a fix me comment, which said we don't have tests for this case, so I added the test and implemented this function for vectors. Some tips if you are new to LLVM backend development: do not spend too much time studying upfront. Instead, start working on a specific change. You can either look at the generated assembly and find a way to improve it. You can pick up a GitHub ticket, or you can work on a to-do or fix me comment. Then you should decide where to do your change. Intermediate representations will help you. And you can look for similar transforms. And the last thing is how to do your change, which is often obvious once you know what change to do and where, and you can ask other contributors for help. Thank you.